Alright, today we're going to be looking at a freely falling object word problem. Alright, so let's say a coin is dropped from an arbitrarily large height, and they want us to find the position and the velocity of the coin relative to the starting position at time equals 2 seconds. And let's also note that there's no air resistance and the coin is initially at rest. So for the answer, we can start by step 1, identifying our givens. So in the question, it says the coin is dropped from an arbitrarily large height. This basically just means that we know that at time equals 2 seconds, the coin will not be on the ground. So we'll know that the coin will still be in the air. Also, it gives us that time is equal to 2 seconds, and it says that the coin is initially at rest. So that basically just means that the initial velocity is going to be equal to 0. The next step is to identify what we're solving for. So in the question, it wants us to find y, the position relative to the start height, and vy, which is the velocity in the y direction. And then step 3 is to identify the equations needed to solve. So we have the position equation, and we also have the velocity equation. And with a question like this, our next step should be to draw a diagram just to visualize what's happening. So we can draw the coin and the ground, and we can let the initial height, y equals 0. And we know that the initial velocity is equal to 0, and we know that that's the position at time equals 0. And then we can also draw a dotted line where the coin will be in the future at time equals 2 seconds, and we know we need to find the position and velocity there. And then we can also draw our g vector. That's going to be our acceleration due to gravity, and we know that's equal to negative 9.8 meters per second squared. So now we have everything we need to solve. For the position, we can start with the position equation, and then we can use the values that we identified in the question, and then we can plug these into the formula, and then 0 times 2 is equal to 0, and then we can distribute the square into the bracket, remembering to square each term. So 2 squared and second squared, we get 4 seconds squared, and then we can plug that into the expression and we get this here. And then we can separate the amplitudes from the units, and we can do the multiplication of the amplitudes, and then we can multiply the units. So for the amplitudes, 1/2 times negative 9.8 times 4 is just negative 19.6. And then for the units, meters per second squared times second squared, the second squareds cancel, just leaving us with meters. So we get this final answer here for the y position equal to 19.6 meters. So I just want to note, this represents the y position at t equals 2 seconds relative to the initial height. So I just draw a diagram here. So we have the coin with the initial height, and we have the time equals to 2 seconds, and that distance right there is what we just found.